Hi guys, this is the video for chapter 9, lesson 3. So in this lesson, we're going to be taking a look at multiplying and dividing exponents, okay? So when we're multiplying and dividing powers with the same base, there's actually some cool things that we see with it. So here's an example here I'm going to do on top. For example, let's say that I have 5 to the third power times 5 to the second power, okay? So if I broke these down just like we did in our last lesson where we break them down into the most simple um, forms of what this power would be, it would be 5 times 5 times 5. And then I'm multiplying this by 5 to the second power. So when I multiply this by 5 to the second power, I have 5 times 5. So if I wanted to rewrite this as a new way to write my power, how would I write this exponent? It would be 5 to the fifth power, right? Okay, so let's do one more. Let's say I have 6 to the second power times 6 to the fourth power. Okay, so breaking this down, I have 6 times 6, and then bring my multiplication symbol down, and then I have 6 times 6 times 6 times 6. So when I multiply all this out, if I rewrite this, it would be 6 to the sixth power, right? So what do you notice about my exponents here and the exponent in my answer? Exponent here and my exponent in my answer. Now, if you guys said that 3 and 2 5 is the sum of 3 and 2, and 6 is the sum of 2 and 6. You are right on it. So what we realize is when we're multiplying exponents, when we're multiplying powers with the same base, you can actually just add these exponents, and that is what your answer is going to be. So 6 to the sixth power. And we're not going to find the final answer from what the power is. I'm not going to multiply that out and find it. This time we're just talking about what our new power would be once we multiply it. So just make sure that you apply this only when you have the same base. If there's different bases, you don't want to apply this method. So let's say I have 2 to the second power times 3 to the second power, okay? When I multiply this all out, I can't rewrite this as like 2 to the fourth power or 3 to the fourth power. It doesn't work because 2 times 2 and 3 times 3, those can't be written as the same power. So just make sure that your bases have to be the same. So we're going to apply this to our monomials where they're being multiplied, but also even some problems with variables. So even like look at example 2 here. Even if you had variables to a power, if they are the same power, we can add those exponents. And so 3 plus 6 is 9. So this would be g to the ninth power. Be careful though, if you have different variables that you can't just add those exponents. So let's find these products and write the answers using an exponent. So 4 to the seventh power times 4 to the sixth power. Well, that would just be the same base and then add my exponents. 7 plus 6 is 13. So 4 to the 13th power. V to the fifth times V to the fourth, V to the ninth power. Okay. F to the third, F to the ninth, multiplied. Even though it's in parentheses, that really just means that they're being multiplied. So I can do same idea that what I've done before. 3 plus 9 is 12. So F to the 12th power. Okay. Looking at number 5, be careful here. So I have a variable C. I'm going to bring this. I'm going to look at this as -1 times C times R to the fifth. And then I'm going to look at this as -1 times R to the second. Now, let's look at this. If we have a negative times a negative, what happens? Doesn't that cancel and become positive? So if you see two negatives being multiplied, then we can look at that as a -1 being brought out. And so we're going to multiply that and it's going to become positive. So now I'm just left with C by itself. And so C is not multiplying anything. And then I have R to the 5th power and r to the 2nd power. So this becomes r to the 7th power. So I have c times r to the 7th power. Okay, so same idea with number 4. If I break down this problem as if I was like a calculator, when I'm reading this, I'm reading this as -1 times 31 to the 4th power times -1 times 31 to the 2nd power. So when I look at this, I've got the same base here, and then I've got -1 times -1, which is a positive. So negative times a negative is positive. So I'm going to write this as a positive 31 to the 6th power. All right. Let's take a look at 7 and 12 maybe, and 9. Trying to pick out some harder ones. So when we have a coefficient, I was blanking on the name, the coefficient. So coefficient is a number that goes in front of a variable. We can multiply those coefficients. So because we can write this as 7 times 5 times h to the 3rd power, right? Because the order doesn't matter when you're just doing multiplication. So 7 times 5 is 35. And then h here, don't forget that if there's no power, there really is an invisible 1 right here because there's one h, right? It's just 1 times itself like 1 time. It's just 1 h. So so when we add our powers, don't forget, don't make it 0 plus 3. It's actually 1 plus 3. And so there are 4 h's. So it's 35 h to the 4th power. So if I just break this down, there's 1 h here, and then there's 1, 2, 3. And so when I count this, I have 1, 2, 3, 4 h's, which means h to the 4th power, okay? So just be careful with that part because it's easy to forget that there's actually like a 1h right here. Okay, number 9. So we only have one negative, and so our answer is going to be negative because I have no other negative to come befriend it and make it positive, right? So 5 times 4 is 20. And then I have p to the 3rd and then p to the 1st. So adding those together, p to the 4th power, -20, p to the 4th power. Let's do 12. So right here, I've got a negative by itself. So I'm going to bring that negative out just because there's no other negative to kind of balance it out. And so my answer here would be 9 times 2, which is 18. And then I'm going to add all my z's, the powers of my z. So I have 3 z's here, I have 1 z here, and 4 z's. So 3 plus 1 is 4, 4 plus 4 is 8. So z to the 8th power, -18, z to the 8th power. All right. I'm going to have you guys do the rest of these problems. So make sure you do all the problems on this page, and we will check answers when we're together in person. So go ahead and do that. And then we're going to talk about dividing monomials. So let's talk about our division here. Let's say I have 5 to the 4th power divided by 5 to the 3rd power. Okay, so if I wanted to write this as a fraction, I could write this as 5 to the 4th over 5 to the 3rd. Now, if I wanted to expand this out, what I would have is 5 times 5 times 5 times 5, 4 times, and 5 times 5 times 5, 3 times. Now, here's the thing. When I have a fraction like this, I could technically write this as a fraction, this as a fraction, this as a fraction, and then this part over 1, right? So if I look at this, what I realize is if I have the same multiple on the top and bottom, that cancels and that's 1, right? This cancels, that's 1. This cancels, that's 1. What I'm left with is just 5 over 1, right? 1 times 1 times 1 times 5. So what I'm left with is 5 to the 1st power. It's just 5. Okay, let's do another one. If I have 5, actually, let's do a different number. Let's use a variable. Let's say I have h to the 7th power divided by h to the 4th power. So I'm going to write this as a fraction 7 times h 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 over 4 h's times h, 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 h. Okay. What I realize is each h, top and bottom, can cancel. And what am I left with? 1, 2, 3. So I'm really left with h to the third power. Okay, I want you to see if you can see a relationship between the exponents. 5, 4, 3, 1. Here you have 3, 4, 7, 4, 3. What do you notice? Well, what I notice is 3 is actually the difference of 7 and 4. 1 is the difference of 4 and 3. So the rule is when I'm dividing powers with the same base, I can actually subtract the exponents. So looking here, I can subtract the exponents and leave my base the same. So 4 minus 2 is 2, negative 8 to the second power. 7 minus 3 is 4, a to the fourth power. Okay, so let's practice this a little bit. This would be 5 minus 2, which is 3, 7 to the third power. 8 minus 6, which is 2, 1 to the second power. 3 over 3. Okay, so that would be, negative 12 to the 0 power. All right, we're going to leave this hanging. We're going to talk about this in a second. Number 4, c to the 20th over c to the 13th. 20 minus 13 is 7, so it's c to the 7th power. Okay, let's go back and talk about this 0 exponent. So if I were to expand out, let's say I have a to the third power divided by a to the third power. This expanded out would be a times a times a over a times a times a. All right, so if I cancel everything, all these, this is 1, 1, 1. Guys, what's 1 times 1 times 1? Isn't it just 1? And well, 3 minus 3 is 0. So a to the 0 power is 1. So what I realize is anytime I have a power to the 0 exponent, the answer for that is 1. So for number 3, the answer for negative 12 to the 0 power is 1. And the logic behind that is the work shown right here. That's the reason why, because when I cancel everything out, it's just 1 times 1 times 1, right? However many times it is, just 1 times itself, whatever. And so then your answer is 1. Okay, so the rest I think is pretty straightforward. Let's do a few like this, just so we can get to the habit of looking at them not just as a fraction. So here I have 3v to the third power, and I'm just going to write it as a fraction to help me kind of see it. So first of all, when you see the same number on the top and bottom of your fraction, numerator and denominator, you can cancel that out. So then the 3's cancel, and now you have v to the third, and what's the invisible number right here? V to the first, right? So then when I subtract, I have v to the second, and that's it. Okay, number 10. I'm going to just write it out as a fraction so that I'm not confused. And 12 divided by 12 is just 1. Then I have 6 minus 2. So this is x to the fourth power. All right, I think you guys hopefully have the right idea. If you're not sure, then come to school prepared with questions, but that's all that you have to do is just finish the study guide. So do the rest of these problems here and you're good to go.